Let's take a look at more on functions and their graphs. And the first thing we're going to take a look at is increasing, decreasing, and constant. Now for our increasing, that's when your graph is going up as it goes from left to right. Your decreasing is when your graph is going down from left to right. And your constant, and I know these aren't appropriate abbreviations, but we'll go with them. Our constant is when your graph is straight across as it's going from left to right. Okay, so our increasing, decreasing, and constant, we are looking at it from left to right. So we're looking at the graph from left to right. And I'm going to put a note here. Only use x values in your actual answer. Okay, let's look at our first problem. Okay, so our graph looks something like this right here. Well, to begin with, this well, actually goes off the screen here, but there's an assumed arrow there indicating it goes forever. Excuse me. As this is going down, it's slowly going out this way. So where it's starting from is clear out at negative infinity, and clear over here is positive infinity. Well, initially my graph is going up, so it's increasing. So it's increasing from negative infinity, and then where it stops increasing at is 1. Remember, we only use our x values in our actual answer. And then it starts decreasing. So it decreases from 1 to positive infinity. Now, some books will put brackets on the 1 to include the 1. Some will put parentheses. They probably both have their own valid explanation of why to use parentheses or why to use brackets. I like parentheses myself, because if you look at a particular point, a point doesn't occupy any space. So you can't say it's actually increasing or decreasing or constant if it doesn't actually occupy space. I'm sure those who like brackets would give you an equally valid reason why it should be brackets. Let's look at our second example here. Let me kind of sketch this down. 1, 2, 3, 4, 5. One, two. There we go. Well, again, clear over here is negative infinity, clear over here is positive infinity. So coming from the left, it's coming from negative infinity. And actually, let me put that first. It's constant. It's straight across. So it's constant from negative infinity, and it stops being constant at negative 1. Remember, we only use our x values in our actual answer. And then from negative 1 to positive 1, it's increasing. And then from 1 to infinity, it's constant again. So those would be our answers. Now the next problems, let me sketch this graph down, and then we'll talk about what these items mean. It's best by showing an example. Okay, so -3, 2, 3, 4, 2, 3, -1. Okay. Now, if you have a point and it's changes from, see how this goes from decreasing to increasing? So it changes from either decreasing to increasing or increasing to decreasing. Then it's going to be what's called a relative min or relative max. This particular one here is going to be a relative min. Now, relative min means with respect to what's immediately around it, it's a low point. Now, this does not say this is the lowest point. This just says to what's immediately around it, it's a low point. So where it changes. So again, it's going down, then it changes and it's going up. So that's our relative min. And to write that down, that'd be -3.50. Now, our relative max. That would be this one here, where it changes from increasing to decreasing. And again, relative to what's immediately around it, it's a high point. Doesn't mean it's the highest point. There's definitely other higher points. It just means what's immediately around it, it's a high point. Well, if you look at this, again, it's going up, hits a high point, goes down. So that's our relative max. And that would be what? -1. Can't hardly see where my tick marks are. -1, 2. And then this over here would be a relative min. And it'll be 3, -1. Again, it's a low point based upon what's around it. So it's going down, and then changes, and it's going up. So those would be our three answers. Now this next one, I mean, there's nothing really too exciting on those. Let me blow this one up, and then I'll talk about how to find the answer. Okay. This notation down here at the bottom says -25, 25, 5. This is our x values. What it's saying is this leftmost tick mark is -25. Next one is -20, -15, -10, -5. So it's going from -25, or rightmost. Trying to be real careful not to touch it. Then it's going to +25, which is our -25 is our leftmost, the +25 is our rightmost, and it's going by fives. Now this next one, the -40, 40, 10, that's our y values. It's saying the bottom tick mark is -40, top tick mark is +40, and it's going by tens. So this is be -40, -30, -20, -10, 0, 10, 20, 30, 40. There's nothing exciting on this problem except for how to read those. Now this up here, it's going up, then hits a high point and goes down, Use your imagination that little dot is at the high point. Okay, this is 2 over here. Well, these go by fives, which means this is -10. So we've got a relative max. -10, and then our y values looks like it's going up to this third one, which is 30. Remember, this goes by tens, 10, 20, 30. So it'd be -10, 30 be our relative max. Now we also have a relative min. It's going down, reaches this low point here, and then goes up. So this will be 2 tick marks over here. These go by fives on my x-axis, so that'd be 10. And then my y values, that's -10, -20, -30. So our relative min would be 10, -30. that. And let's talk about the next topic now. Actually, I guess I'm ready to save that page. Actually, I don't need to save it. It should already be, pages should already be out there for that one. Let's see, section 2.2, yeah, I got pages out there. And time for my little tablet to blow up. Let me describe how my day's gone so far. I woke up fairly early, and I wasn't feeling very good. So it's kind of gone down like that. And then went down and got me a pop, and that always makes me feel better. Came back, I started recording. That made me feel better, and still recording. I'll probably have to go out pretty soon, maybe do a little bit of work, maybe. If I do a little bit of work, my day's going to shoot down like that. Come back, and if I do a little bit more math, that'll go up. Let's see, TV tonight, there's no Big Bang Theory, so that's going to go down. Let's see, nothing good on TV, and so that's how my day's going to go. There's no way we can get a graph to fit that, but what we can do is we can break these into pieces, like this. Now, by breaking it into pieces, I can get a model for this piece right here. Maybe this is y is equal to negative 2x. I don't know. Maybe this piece right here is y is equal to x. Maybe this piece right here is y is equal to 1/2 x. So by breaking it into pieces, then we can model it. That's a concept of piecewise functions. We can never get something to completely model our data, but we can break it into pieces, and we can. Okay, so these first ones are just evaluating. So let's take a look at those. We've got f of x is equal to 9x plus 2 and 8x minus 1. It says if x is less than 2, and this one says if x is greater than or equal to 2. And let's find part A. We want to find f of negative 5. Now remember from before, whatever number's inside the parentheses here is your x. So they're basically telling you x is equal to negative 5. Now our piecewise function up here says this. This is how it's written. 9x plus 2. It looks like that when x is less than 2. Now it looks like 8x minus 1 when x is greater than or equal to 2. Well, if I come down here, I got negative 5. You look to first your conditions over here, and you see where does that fall at? Is negative 5 less than 2, or is negative 5 greater than or equal to 2? Well, it's less than 2. So I'm going to plug it into this first piece. So I'll take 9 times negative 5 plus 2. That gives us 9 times negative 5 is negative 45 plus 2, which gives us negative 43. B is f of 2. Now again, whatever number's inside the parentheses is our x, so they're telling us x is 2. And we're going to look up here and look at our conditions. And you're trying to see where it falls. Is 2 less than 2, or is 2 greater than or equal to 2? Well, it's not greater than, but it is equal to 2, so it's going to fall into our second piece. So that's where I'm going to evaluate it at. So I put the 2 into the 8x minus 1. And that gives us 16 minus 1, or 50. Grab a drink. And we're finding f of 8. Okay. Again, the number inside the parentheses here is your x, so x is 8. We're coming over here to conditions. Is 8 less than 2, or is 8 greater than or equal to 2? Well, it's greater than 2, isn't it? So it's following our second piece. So we'll plug the 8 into the 8x minus 1. Now it gives us 64 minus 1, or it gives us 63. Now when I put these on a test for evaluating a piecewise function, if you plug it into both pieces, I'll take every point off. The goal of this is not for you to show how good you are at evaluating a function. They're usually pretty simple to evaluate. The big goal of it is for you to figure out which piece to plug it into. Not to plug it into both of them. That's not like double the work so you get double the credit. You get 0 credit in my class. Let's look at another one of those. So we got h of x is equal to 7x minus 1 over x plus 2 and then 4. So it looks like this when x is not equal to negative 2, and it looks like this when x is equal to negative 2. Our first one, we want to find h of negative 5. Again, whatever numbers inside of parentheses is our x, so they're basically telling us x is negative 5. So we come up here and compare it against our conditions. Is negative 5 not equal to negative 2, or is negative 5 equal to negative 2? Well, it's not equal to, so we're going to plug that into our first piece. So again, where our x is, we put in parentheses, and we're going to plug in the negative 5. Well, 7 times negative 5 is negative 35 minus 1. Negative 5 plus 2 is negative 3. That gives us negative 36 over negative 3, or it gives us positive 12. Okay, h of negative 2. Now again, whatever's inside your parentheses, it's going to be your x. So they're basically telling us x is negative 2. So I'm going to come over here and compare it against my conditions. Is negative 2 not equal to negative 2, or is negative 2 equal to negative 2? Well, it's equal to negative 2. So we're going to plug into this piece. This is actually so simple it's hard. There is no x to plug into, so actually our answer is just 4. Let me do C over here. C is h of 4. So, my wife. So I'm going to be disrupted by her and lose my train of thought. Let me see, what am I doing? Okay, h of 4. Again, our x value is what's inside of parentheses, which is 4. So I'll come over here, compare it against my conditions. Is 4 not equal to negative 2, or is 4 equal to negative 2? Well, it's not equal to negative 2, so we're going to plug it in our first piece. So I got 7 times 4 minus 1 over 4 plus 2. That gives us 28 minus 1 over 6. Gives us 27 over 6. And this reduces. Top and bottom both divisible by 3. So that gives us 9 over 2. So 9 halves is our answer. Let's look at the next problems after my tablet gets done blowing up. There we go. This is a graphing one. Got f of x is equal to x minus 3, x plus 1. And this one looks like that when x is less than negative 2. It looks like this when x is greater than or equal to negative 2. And this is graphing piecewise functions. Okay, our first step. Graph each piece separately. So graph each piece separately. So we got y is equal to x minus 3, and we got y is equal to x plus 1. Now you could graph these in whatever manner you see fit. Y is equal to x minus 3. Okay, that's shifted down 3. And looks like that. Okay, y is equal to x plus 1. That's up 1. Looks like that. Not that can't draw straight lines, but then step 2. Apply your conditions. Okay, so it looks like x minus 3. Looks like this one right here when x is less than negative 2. So what I'm going to do is I'm going to take this, and it's like we have an invisible line here at negative 2. And we're going to erase either the left side or the right side. Well, this tells us to keep when x is less than negative 2. So I'm going to keep the left side. That's where it's less than. So I'll keep that piece right there. Okay, now this other one. This is true when x is greater than or equal to negative 2. So again, same type of thing. I go to where negative 2 is. And there's like a visible line here. And I'm going to keep either the left side or the right side. Well, this is where it's greater than, so I'm going to keep the right side. Yeah, I'll try it again. And we'll keep that piece right there. Okay. Now x is less than negative 2. That doesn't include negative 2, so this is going to be an open dot here. Now x is greater than or equal to, that includes that, so we're going to put a closed dot right there. Okay, step 3. We're going to merge into one graph. We want to merge that into one graph. And this is just sketching. I mean, don't, at least in my class, don't spend a huge amount of time on it. So this would be that piece, and then this one would be right there. So that'd be your answer. Let's take a look at how to do this on the calculator. And let me write it over. I got f of x is equal to x minus 3 and x plus 1. X is less than negative 2 and x is greater than or equal to negative 2. Okay, the key to graphing these is put parentheses around x minus 3, put parentheses around the x plus 1, and put parentheses around your conditions like that. And then we're going to put this on y1, we'll put this on y2. Now on the T83s, these won't look very good. And you may find it easier just doing by hand than to fool with technology in this case. Usually I'm pretty big on calculator, but not sure if these add very much. I'll press y equals, press clear. Okay, so I do my beginning parentheses, and then I got x minus 3. Put a closing parentheses, beginning parentheses, x, and then next one is less than. Where you find less than is underneath the test menu. So I'll do second math, and less than is my fifth one, so I'll press 5. And this would be negative 2. Close parentheses. Then I'm going to do a down arrow. And do a beginning parentheses, x plus 1. close parentheses, beginning parentheses, x, and this is greater than or equal to. So I go in the test menu again. So I do second math. Greater than or equal to, well, my eyes are bad. I think that's 4. And then I'll put in a negative 2. Close parentheses. And then graph. And more precise than what I came up with, but that's your answer. The one thing it doesn't give you the open and closed dot, and you have to recognize when to put that. Now, what's wrong with the TID3? It puts a vertical line on there. So if you exclude everything except for that vertical line, then basically you have the same graph. Well, let's take a look at another one by hand. And now I'll try to remember if I remember how to do this one on the calculator. It's a little bit tricky. Okay, so I got negative 2x and x squared plus 3. This is if x is less than negative 2. This one if go from negative 2 to 0. And this one where x is greater than or equal to 0. Grab a drink. Okay, first thing I'm going to do is graph each piece separately. So look at y is equal to 2, y is equal to negative 2x, and y is equal to x squared plus 3. Okay, y is equal to 2 looks like this. Y is equal to negative 2x. Looks like this. And y is equal to x squared plus 3. Looks like that. Okay, now let's apply our conditions. Okay, so y is equal to 2. It looks like that when x is less than negative 2. So I come over here. Here's negative 2. And it'll look like that when it's less than negative 2. Now it's less than, which means this is an open dot. Okay, so it looks like this between negative 2 and 0. And I didn't draw that real good, but what I'm doing is at negative 2, if I put negative 2 in here, negative 2 times negative 2 is 4. So I know this is a point. And if I put 0 in, that'll give me 0. So it's going to look like that right there. So I should have been a little bit more of an angle here. So again, we're keeping the part of the graph that's between negative 2 and 0. Now negative 2 has a less than or equal to, which means this is solid. And this has a less than, which means this is an open dot. Now this one looks like this when x is greater than or equal to 0. So we're going to keep where x is greater than or equal to 0, which is the right side here. It's greater than or equal to, which means this will be a solid dot. Okay. Then step 3, merge those into a single graph. So we'll have this piece. And then we'll have this piece, and then we'll have that piece right there, and that's our answer. And okay, the key on this to plug it in your calculator, and actually let me just write it over. I'm out of space. So I got 2, and this will be x is less than negative 2. And notice I put parentheses around 2, and I put parentheses around x is less than negative 2. Then we got negative 2x, parentheses. And see how this is negative 2 is less than or equal to x is less than 0. What this is saying, if I cover up the less than 0, that's saying that x is greater than or equal to negative 2. So greater than or equal to negative 2. I'm reading it backwards. X greater than or equal to negative 2. And if I cover up the negative 2 and the less than or equal to, the last part, we just got x is less than 0. That's what that's saying. And that's how you have to put it in your calculator. So it's kind of a pain. That's what I say. It's almost as easy to just do it by hand. And then this other one is x squared plus 3. And then parentheses around it. And then x is greater than or equal to 0. Well, this one I'll put in y1, this one I'll put in y2, and this one I'll put in y3. So let's look at this on the calculator. Press my y equals, I press clear on the first line, down arrow, press clear on the second, get that all cleaned out. Okay, go back to y1. So I have beginning parentheses, 2 closing parentheses, beginning parentheses, x is less than, so I do x, go to my test menu. Second math, less than is 5, Mr. Magoo says, and then negative 2, closing parentheses, down arrow, beginning parentheses, negative 2x, closing parentheses, beginning parentheses, x is greater than or equal to negative 2, so I do x, go to my test menu, greater than or equal to is the fourth one, negative 2, go back in my test menu, second math, right arrow over to logic, and I want to choose and, which is my first one. And x is less than 0, so I do x, go in my test menu, less than was 5, 0, closing parentheses, down arrow. Okay. And then y, it's x squared plus 3 inside of parentheses. So beginning parentheses, x squared plus 3. Closing parentheses, beginning parentheses, x is greater than or equal to 0. So x, go to my test menu, second math. Greater than or equal to is the fourth one, 0, and then closing parentheses. And then graph. And of course I've wiped out my graph, but that gives us our same graph. It doesn't do the closed dot and the open dot, and it does look pretty bad on T83. It has those vertical lines, and in some earlier models of T84 it does that too. But anyway, that's how you plug in your graphing calculator. Now be sure, once you get that all done, and once you're happy with it, assuming you like to use technology for that, press your y equals and press clear on all 3 lines. So press clear, down arrow, clear, down arrow, clear. Love when the graphing calculator makes your life easier, but I'm not sure if this actually makes it any easier. It might make it a little bit harder, which goes against my grain. And I believe we're all done with that section. Yes, indeed we are. So I'll go ahead and finish the recording here.